After the last writing assignment, I noticed that there are quite a number of people who have a bit of a misunderstanding when it comes to springs. So I thought I'd do a quick demonstration here on video so that you can see exactly how gravity plays a role in springs. It turns out it doesn't play an important role when it comes to the period of a mass on a spring. So we're just going to do a quick experiment here and show you how it works. First of all, we have one of the masses that you guys used in the lab, and we see what happens when we put it on the spring. The spring would normally be just hanging at some distance, but when we put it on the spring, it now stretches it out. That's Hooke's law. So the weight of the mass that we just hung off the spring has a force, and that force has to be balanced by the spring force, so mg equals kx. That's not the important part. The important part is when we set it in oscillation. Right now everything is balanced. We have an equilibrium position, and if we give it a little shot, it will now move from its equilibrium position. But that's the most important thing. It's in equilibrium. Whatever it's in, when it's not moving, that's the equilibrium position. Then if I give it a little amplitude, it will now oscillate about that equilibrium position. That's all that matters here, that there was an equilibrium position and it is now oscillating about that equilibrium position. It doesn't move farther because it's heavier. It just hung down farther, but the amplitude is whatever I give it. Now let's try it with a different mass. Try my coffee cup here. I take my coffee cup is lighter than that aluminum mass, but I'll give it a similar amplitude. So it's hanging down a little bit less because it's less heavy, but it is not moving less. The amount of motion I give it depends on the amplitude I give it, and I can set that. And you can see it's lighter, so therefore it's moving around much more quickly. Why is that? Because it's lighter, it's easier to accelerate, so the spring force gives it a greater acceleration, and therefore it takes less time to do an oscillation. That's it. So I hope that clarifies it, and if you have any questions, send me an email.